Good morning, good evening, good afternoon, and welcome to everyone who has joined us today. I am Senior Associate with Stratview Research, and I'll be your host and moderator for this session. So, this is another session of In Conversation with Stratview. So, today we will be deep diving into a very pivotal question for the future of manufacturing. Will sustainability push biocomposites into mainstream? And to help us unravel and unpack this, I'm joined by a leader who has already spent decades at the intersection of innovation and environmental stewardship. So I have with me David Saltman. So David is a successful executive and clean tech entrepreneur. He is the chairman CEO of INCA Renewtech, a company focused on the utilization of Canadian hemp in the production of natural fiber composites for the automotive, marine, wind energy, consumer products, and other industries as well. So Inca was the winner of the New Products and Material Award at the JEC World in Paris. He was formerly associated as the CEO of Malma Composites, manufacturers of the first rigid urethane foams made from bio-based resources. Malma received many awards, including Most Innovative Green Product from the Society of Plastic Engineers. Before this, he has served as a CMO of Flex Technologies, the first natural fiber composite company in North America. Now, Flex material enabled engineers at Ford, GM, Chrysler, Toyota, and Tesla to produce automotive interiors that were stronger, lighter, and far more easily recycled than glass reinforced plastics. For this work, he received the Excellence in Innovation Award from the American Composite Manufacturing Association. Please welcome David Saltman, everyone. Hey, David, how are you doing today?
Thank you, Pranab. It's wonderful to be with all of you. Thank you very much for having me.
David, do you want to add one or two lines about yourself in case I have missed anything?
No, I think that's quite enough. You know, you reach my age and it's a long history. I try to tell future stories, not back history, but it is true, though. I came out of a very different industry. I was actually educated as a filmmaker. I came out of UCLA Film School, and and we actually created the E-Entertainment Network, the E channel, which is still up and running. And when I was always interested in the environment, and when we sold E-Entertainment to Time Warner during their merger, that enabled me in a fairly young age, in my early 30s, to really decide to go a very different turn in my career. And I was passionate about the environment and about sustainability. I just thought the environment was too important to be a charity. And so I wanted to see if it could be a business. And that's been a 4-decade journey of exploration and innovation. And so, I'm just happy to come and talk with all of you.
Well, thank you so much, David, for just telling us about your journey right from E Entertainment Network. Even I believe you produced a movie, Psycho 2, if I'm not wrong.
Yeah. Obviously, you've taken the deep dive in my history. I'm glad that a lot of that life I led in the entertainment industry was pre-internet, so there's not a lot of, bad stories to tell, right? It's less tracing than today.
Right. So what we can do is we can quickly dive into your experience with composite industry, right? Now you have been associated with composite industry, and since this industry has always been dominated by fiberglass, petroleum-based plastics, and other synthetic materials because of their obviously established performance, scalability, and manufacturing maturity. Now, in your opinion, what has been the biggest technical as well as industrial challenges in bringing biocomposites adoption to the same level as traditional composites?
No, it's a great question. I would say that the largest factor really is economies of scale. When you're competing against, the plastics industry, a $580 billion industry with 100 years of experience in vertical integration, basically maximizing extraction of oil into ethylenes, propylenes, as you say, glass fiber. Um, the, they are really some of the largest companies on earth. And so when you're creating a new set of materials, one's based on not hydrocarbons, but carbohydrates, you have to achieve a certain scalability and vertical integration to be cost competitive. So I would say cost competition is probably the greatest barrier. I think the other thing is that, you also have to recognize your competition is incredibly valuable and versatile. Plastics can be shaped into colored into any color. They can be tuned to resist heat. They can be basically, the materials themselves are very low cost and very, very flexible in terms of their applications. And so I think that from a customer's point of view, glass fiber reinforced plastics are a very compelling material. But here's the thing, the extraction and the refinement of petrochemicals is incredibly carbon intensive. And it generates a ridiculous amount of air and water and land pollution. And the other thing about these materials is that they never biodegrade. They just get smaller and smaller, and they carry hundreds of different toxic chemicals, whether they're surfactants or fillers or colorants or materials. And those chemicals then are carried in these small particles that are now found in every living organism in the world. So I like to say that biocomposites are really the solution to this pollution, and that's where I was coming from in entering this industry.
Got it. So just help me understand. So were tightening global regulations by government, and now corporates also are also moving towards net zero commitments. So were those also were driving factors for you to hop into biocomposites?
Well, there are definitely incredible external market factors in our favor. I mean, there are government regulations which are trying to reduce plastics pollution and certainly reduce single-use plastics at all entirely. If in Canada or in Europe now, if it doesn't biodegrade, then it's not allowed to be used as single-use plastics, whether those are utensils or other kinds of items that basically use, packaging that's used once, thrown away. So there are regulations in place, but I would say primarily the biggest factor for us in our favor is industry policy. So when we deal with a company like Toyota, they have a Vision 2030 and 2050 plan, and it includes life cycle analysis, but it also has market drivers like they want things lighter. They want to reduce the weight of vehicles because, as you know, batteries are heavy, and they're really trying to maximize the amount of mileage they can get out of every volt. They want to see life cycle improvements so that at the end of vehicle life or at the end of product life, these things can be recovered and recycled back in. And biocomposites provide a pathway that glass reinforced plastics don't. When our work with the auto industry, we not only made cars lighter, we made them less expensive. We took molding times for Ford from about 4.5 minutes down to 48 seconds. That final part, that door panel or seat back or headliner, was also 25% lighter to 30% lighter. And because glass fiber, as we know, has very high tensile strength, but it actually has fairly low impact strength. And in a vehicle, in a collision, where you get cut is not from the glass in your window, it's from the plastics, glass reinforced plastics in your interiors. And natural fiber have this ability to be much more resilient. So we also made safer vehicles. So better, stronger, lighter, cheaper, green. It worked out pretty well at Flex Form. And we're trying to replicate that success now up in Canada with INCA Renewable Technologies.
That's quite interesting. So I just want to also touch base upon the material side of business as well, right? And I want to show one slide, or rather, it's not a slide, our market intelligence tool, right, which we call as Stratview lens. Let me know once my screen is visible. I hope you can see it.
I can.
Perfect. So this is for everyone. So this is basically our market intelligence tool, and this basically covers all the decade-old work that we have already done in composite markets as well as aerospace and defense. Now, what I have opened right now is global natural fiber composite market. And when you see from materials point of view, Flex as market share has 73%. That's what we visualize right now. And hemp is somewhere around 10.3% of share in overall global natural fiber composite market. Now, my question to you, David, is since Flex has long been a staple for automotive interiors, now, from your perspective, what gives hemp the definitive edge for global industrial scaling? Is it superior structural performance or anything else?
Well, for us, it's a number of things. So when we created the first natural fiber composites company in North America, as you pointed out, Flexform, we were entirely reliant on importing clean, textile level, clean natural fiber from Southeast Asia. We were primarily using KNAF, which is related to hemp, extremely good fiber, and jute. We have also experienced with flax as well. So these are the bast fibers. These are fibers that can be processed into very clean fibers. But while we were importing those fibers, we were paying about 80 cents a pound for that material by the time we got it offloaded in our factory in Indiana. That's about the same price as glass fiber. So when I moved from California up to Canada, what I realized is Canada has been growing hemp for plant-based protein for 20 years legally, okay?
Got
And
it.
that that stalk that grows, when they harvest the seed for protein and for oil off the top of that hemp, the remaining biomass contains some of the strongest fiber on earth, no question competitive with flax or KNAF or jute. It's incredible fiber, but it was being poorly utilized or burned in the field as a waste stream. So we came along and we said, look, let's have the farmer make his money on his grain, and we'll come along and buy his waste stream, his biomass, for another $150 a ton. And all of a sudden now, that hemp becomes one of the most valuable cash crops in the prairie. And
Got
it
it.
becomes a regular rotational crop with his wheat and canola and yellow peas that are grown up in that same region of the Canada. But what it did for us was it dropped our raw material costs because of our vertical integration, our ability to process that hemp, decorticate it into very fine materials, very clean materials. All of a sudden, we dropped our raw material cost from that 80 cents a pound down to 8 cents a pound. And so INCA will be not only cost competitive, we can be lower cost than glass reinforced plastics, right?
Right.
So it's an incredibly compelling story, and that is all enabled by our ability to do all of the work ourselves, not rely on other people to process the fiber, but we ourselves within our factory will both do the decortication, the cleaning, and then the processing into composites. Now, because we want to be a zero waste facility, that motivated us to develop and patent a set of products. So rather than just making one product, a non-woven that we were doing at Flexform or what we were doing at Malama Composites with bio-based foams, we actually want to utilize 100% of the stock that comes into our factory. So what happens is, as we process it and clean it, we get very long outer fiber called bast fiber, and call it 30 to 36 millimeters in length. That material, those longer fibers, we interlace, if you will, with polypropylene fiber, and we make a non-woven mat. And that non-woven is a prepreg. We call it INCA prepreg, and that is used for compression molding of door panels and seat backs and drone bodies. Now we have a lot of interest from a couple of big defense guys in lighter, stronger, and by the way, very low signature components for that industry. The short fiber that we generate while we're beating up that hemp stalk, which is very tough material, the short fiber, call it 4 to 7 millimeters in length, that we actually compound into pellets for injection molding. So that can be used for an infinite number of consumer products for injection molding, also automobiles and other types of products. And we can compound that fiber with, say, a bio-based resin system like PHA or PLA to create 100% biodegradable knives, forks, and spoons for McDonald's, but also a whole host of other products. If you want biodegradable Legos, we got it for you. So very, very unique in that. And finally, when we get that hemp bale in, about 50% by weight of that stalk is an inner core material called hurd. And hurd is very lightweight. If I gave you a piece of it in your hand, it would feel like cork and it would float on water. It's very fine fiber, and we have, again, developed and patented a methodology to take that inner core, pulp it, dry it, and press it into ultralight fiberboard. And this is called INCA BioCore. And INCA BioCore is a direct replacement for balsa wood and for high density foams in boats and turbine blades and a whole host of other things. And it has much higher properties and much lower cost than balsa wood or PVC, high density PVC foams. So we're driven by our values, if you will, our sustainability values has motivated us to develop materials that enable that kind of behavior. So our factories generate zero waste, water or air pollution. They're highly energy efficient. Our products are entirely non-toxic and able to be recovered and recycled. It's very much in our triple bottom line, if you will, DNA to motivate in this regard. So I know that's probably a long-winded answer to your short question, but it shows you sort of necessity is the mother of invention, and this is some of the work that we've been doing in this last couple of years in preparation for launching this factory.
So what I've understood is INCA is not only cost effective, but at the same time energy efficient, as well as at the same time you are very innovative with your products with prepegs and biogas and everything, right? So that brings me to my another question, right? And again, I'll go back to my market intelligence tool, and when see the end use industry, I know INCA is already very big with automotive, and over here also we see that automotive for global natural fiber composite market is 96.2%, right? Now INCA is already supplying prepegs to Toyota, and automotive is currently heavyweight champion of biocomposite adoption. Now, as a CEO, where do you see, your next low hanging fruit for mainstream dominance? So that will be my next question to you.
No, it's a great question. So having lived through automotive wars, I like to say the auto industry loves you and then it loves you to death. And it's, in terms of its forcing down pricing and margin. So as a CEO, I would like to see our market mix be no more than about 25 to 30% automotive, to tell you the truth. And so I really like a couple of other big industrial sectors. I mentioned one before, which is single-use plastics. So I really think there's multi-billion-dollar opportunities globally to replace styrene plastics in all these single-use applications with our injection moldable INCA bioplastics made with a polymer, compounded with a bio-based polymer, so that once you use this packaging or use these utensils or plates or all those things that we throw away, that first of all, they'd be resilient enough to work in that regard and then biodegrade entirely. And so they would never enter landfill or create microplastic pollution. So that's a huge opportunity, and that's driven by legislation as well as consumer sentiment to reduce plastics pollution. Another area that I think is absolutely fascinating, and I actually have a family history in it. My grandfather was a big modern furniture manufacturer in Los Angeles. And I've always had an interest in architecture design and interior design and furniture. And an ultralight MDF, if you will, that INCA BioCore material, IKEA is a wonderful product, right? But the problem is that it weighs a ton. You get a hernia trying to get it upstairs to your kids' room to make their shelves or and so imagine reducing the weight by half or more than half and be able to have ready to assemble furniture that would be very lightweight, would ship for a lot less money and be made out of sustainable materials. So I think there are whole sectors that we could talk about, even with the prepregs. The INCA prepregs are really, our experience has been in automotive. But as I said, aerospace now has a serious set of needs around new materials. And the volumes that people are looking at in that world are astronomical. So I don't think INCA's challenge is going to be market constrained. I think our challenge will be capacity constrained. We will be forced to expand. In fact, our factory is being developed to be able to be expanded and add lines. And then we'll also be forced to manufacture around the world. It makes much more sense to if we're dealing with Indian manufacturers, to manufacture in India. And to your point earlier, we're fiber agnostic. So hemp may not be legal in India, but certainly jute and canaf is, and we can easily source it. So our market focus is really slightly different. It's really choose, as you point out, the low-hanging fruit. Where are the margins? Where's the money going to be made? You don't want to have infinite numbers of SKUs. You really, as an earlier stage company, you want to reduce your number of different products that you're manufacturing to 4, 5, 6, 7 versions, and then that goes out into the world, right?
Right, I totally understand. And that brings before I jump into my next question, I would like my audience to keep on posing their question, and we'll be taking your questions at the end of my questions, right? So good that you have brought that aerospace is one industry that you want to really explore, right? So while also talking to my customer, so from a sales side and business developer side, I speak to a lot of customers. So we have seen reports on emerging opportunities in aerospace cabin interiors, 3D printing filaments, as well as even recyclable wind turbine blades. Now, so how soon do you think biocomposites can meaningfully enter these high performance industries? And what is the tipping point for these sectors?
So, we've addressed a couple of them. In my experience, in clean tech companies, we've said it a couple times on this conversation, but you've got to be cost competitive, and you have to. That's job one. So you can be stronger lighter, greener, but if you're not cost competitive, you know, market research says that consumers will pay a premium for green. Don't believe it. Toyota will not. Beneteau boats will not. So you got to be in that ballpark. The other thing is you have to have enough volume to enter these industries. You know, if I come to, you know, the Lockheed with the best material in the world to make a drone body, and by the way, natural fiber composites don't bounce radar signals very well, so there's a whole interest there. They're lighter, but they're also much more stealthy. But if I come to those guys and I've got the greatest product in the world, and they say, "Great, we need 4 million square feet of that," and you say, "Yeah, but I can only make a couple 100,000 square feet of that," it's a non-starter. So one of the challenges for us has always been, and INCA, because we're servicing these big industries, is you have to build large. These are large industrial scale facilities. I mean, our decortication line, each decortication line is 600 feet long. I mean, the pre-preg line moves at 10 square meters, you know, a minute. You're talking about high volume, continuous, highly automated, expensive, sophisticated facilities.
Right.
And that's critical to getting to your cost numbers, but also to the volume numbers that enable adoption. But I'm saying this in, you know, people talk about biocomposites as it's just a little funny thing. I mean, your market research has already showed you it's already a $35 billion industry in biocomposites. I mean, it's a real industry. I think now it's critical to continue to advance the materials to be able to look beyond automotive into these other areas and really get much wider adoption, market adoption. But I think the story of the materials is very compelling. You know, I never get pushback with the story. It's just, can you hit my price points? Can you hit my volume numbers? And show me the numbers. In other words, show me your structural properties. Is it dimensionally stable? Does it absorb moisture? You know, can you make it consistently, same material, day in, day out for the next 5 years? You know, if I'm at Ford or Toyota or Tesla in a program, it's a 5-year, it's a long adoption cycle. All the testing gets done. PPAP has to be, your plant has to be PPAP certified, anyway, set of certifications. But then they want to see that same material. And that's been one of the real challenges of people entering biocomposites is you're dealing with an agricultural material. So how do you make sure that fiber, year in, year out, season to season, sometimes less rain, sometimes more rain, sometimes higher moisture content when it comes into your factory. How do you equalize this, you know, amorphous, you know, living material into consistent composites? When you're dealing with glass and you're dealing with ethylenes or propylenes or carbon, you know, that inorganic can be done very consistently. But so you really have to know, we actually have to know a lot about field agronomics and genomics to get what we need. We actually work with our farmers to say, look, here's the spec on the fiber we need. Here's what to plant to be able to yield grain and yield good fiber. So it's very much a relationship all the way back into the field. We are not farmers, by the way. We're buyers of fiber, but our spec is our spec, you know.
Right. So do you think standardization of supply chain is one point where you can overcome these challenges that you have just mentioned?
It is a challenge. Now, you know, you mentioned earlier hemp, and I think people forget that not so long ago, hemp was one of the most widely cultivated plants on Earth, period.
Right.
Britannia could not have ruled the waves without hemp rope and hemp sails. That's what that canvas came from. If you were a colony, you had to by law grow it. so that they could source it locally when their ships were around the world. It wasn't until the 1930s that hemp stopped being widely cultivated, and that was for political reasons. For two reasons. DuPont created nylon. What was the problem with nylon? It wasn't as strong as hemp. So let's outlaw hemp and throw it in with marijuana and confuse those two things. They're entirely different, plants. One has THC content, the other has no psychotropic properties, but they did that. And the other political force was William Randolph Hearst, who made newspapers, and hemp was used up until that point to make most paper. And Hearst had a lot of forests. He owned a lot of trees. And so he worked with DuPont to outlaw hemp around the world in order to, enhance the value of his forest for his newspaper, his pulping operations. So that is being turned around, my friend. That hemp is going to be grown around the world again. It's already happening. It's happening in the States, even though the States had a bumpy ride. And even in India, you're going to see the return of that as a cultivar.
I mean, that's quite fascinating. I wasn't aware about this political and historical things that you've just mentioned. So thank you so much. So now let's talk about INCA, your brainchild. Now, your company INCA Renewtech has built application across remarkably diverse range of industries, right? And you've already mentioned, right, from automotive to RV panels for Winbago and specialized boat cores, right? So, what do you believe INCA is doing differently that has enabled the company to gain such strong industry traction, right? Is it your vertically integrated supply chain that you have just mentioned, or perhaps plug and play nature of your bioplastics pellets?
I would lead an answer to that really my chief technology officer, Gary Balthus, who's really the godfather of natural fiber composites. Gary and I have worked together for many years, and what he preaches is quality. Quality, 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 consistency. And that's where a lot of people fall down, is that they're not disciplined or knowledgeable enough to realize that, for example, on a prepreg material, we have to be plus or minus 5% thickness and density year on, year out. And to do that, you really have to adhere to very careful automation of quality controls, weight loss feeders, densities, material specs, measurement along that line. And so I would say that one of the real keys to INCA's success will be our ability to deliver very high quality materials. The other piece of it is really about innovation. So we don't invent something and then go out to customers. We enter into joint development agreements with customers to develop something that meets their specifications and their cost and performance numbers, and then we see if we can make that product. And so we build in the customer in our development effort. McDonald's wants biocompostable utensils. Great. What do those need to cost? What kind of volume do they need? Well, it turns out they need 30 million pounds of that in US alone, right? So we have to look at our production line and go, okay, we're going to have to size that line in this kind of way, right? So I would say part of the key is our quality, our just religion built around quality. And the second thing is really customer-centric focus. So that, we've seen other people have even in Canada wanted to do hemp biocomposites, and on their website they have biocomposites, but they really don't understand the rigors of some of these industries. And I think that just comes with years. I got this gray hair for a reason, man. I earned it. You have to really, really be committed to your customers, develop close relationships with them, and deliver what they need. And some things you just have to walk away from certain opportunities. There's opportunities that come about where you look at the market, but you realize the adoption cycle is so long that there's other uses that are more immediate and even more valuable. So that you have to weigh in from a business standpoint. So my CTO may be developing, he's got dreams to develop 200 SKUs of materials, and I'm saying, like, you get 5, that's all you get.
Got it. So now, I want to dive into, and I have to ask two quick questions, right? Probably, and you can definitely take as much time as you want, right, to answer this, because this will definitely, I want to dive into your vision, right, for 2035 till 2035, right? So, David, having secured prestigious JEC Composite Startup Booster in 2023 award, and you have already received support through Alberta Innovates grant. So INCA is right now is clearly at an major inflection point. With such strong validation and industrial capacity, do you intend to seek further funding to fuel your global scaling strategy? And if so, would that capital be prioritized for regional expansion into new markets?
Well, I will tell you that the largest challenge for INCA was not assembling the band, getting the best people in the world. It wasn't even the design and engineering of the factory. The biggest challenge truly was capital raising. I expected to be capitalized several years ago. It was a perfect plan, a perfect management team, proven track record, all this stuff. And they were the capital markets were just extremely difficult. We are too big for venture capital. In other words, like, we're a big, massive startup in their lines. Like, this is a 70 million, $80 million USD venture to get this factory stood up and get going. So too crazy for venture capital, and then too early stage for private equity, which private equity primarily likes to purchase cash flows and then, scale businesses that are already up and running and clearly in revenues. So we kind of were in that middle thing, and we were fortunate enough, and this will be announced soon. I don't want to announce it here of who
Sure,
the
sure.
funding source is, other than to say that it's a sovereign wealth fund with very deep pockets, not infinite, but I would say infinite in my mind, certainly, who want to deploy a lot of capital now in Canada based on Canada's resources and opportunities. It's a strategic move on their part. They will be investing not just in INCA. INCA will be their first investment in Canada, but they are also investing in other industrial sectors, for example, oil and gas. They're also in residential and commercial real estate, but INCA represents what they call their advanced materials division. And INCA will play a very strong role in not just the factory we're building, but in identifying other opportunities in biocomposites and advanced materials that we would like to see come under that umbrella. Their second interest once INCA's running, is to take us around the world, and they will finance that entirely. So our customers basically will demand Indian auto manufacturers want to source in India, right? European auto
Right.
manufacturers, same way, will have to be in Mexico. So those are sort of the first 3 on our list, to tell you the truth, would be Latin America, India, and Europe. We have very strong relationships, and so we'll do that through license and joint venture. We're not going to just come in solely and build a factory. We'll do it with local partnerships, and so we're very fortunate to have that opportunity. It took a long time to finally get to that point, and now we're there. So we're just finishing up all the paperwork, and then in the next couple of weeks, you'll start to see announcements about much more public facing. I've been in what they call a quiet period, where we've really just been heads down in a public profile way, but that's about ready to change.
Got it. No, no, I mean, fingers crossed. Definitely, you
Thank
will.
you.
But
Appreciate it.
the kind of while doing my research, the kind of funding rounds that you have gone through, it's quite impressive, right? Right from 2021 to 2023, and 2025. Uh, I'm an optimist, so I definitely believe that, and I believe in Inca's vision, and just I and that's why my next question to you is regarding your brand identity, right? In your brand identity, you have noted that Incan civilization understood sustainability through an agrarian economy long before we all did. Right? So, if we were having this conversation again in 2035, what achievements would you hope to be celebrating, both for INCA Renewtech as well as for a broader biocomposite industry as a whole?
I think you just hit on it. I mean, a rising tide lifts all boats, right? So I would love to see this industry we're calling, biomaterials, bio-based materials, far exceed even what the pundits are predicting it will do. That would make me joyous if, 10 years from now, we really see the real takeoff of this, that people all over the world are scaling it. People are creating very unique polymers, very unique products that really understand and can celebrate carbohydrates as opposed to hydrocarbon based materials. I think that is just sort of job one, is to support the entire industry, which I try to do personally. Um, I think in terms of uh, funding, that really the capital markets see this as in a much broader area, and that capital, whether it's early stage angel investing and venture money, to scalability and private equity, to large funds, really get behind this trend, realize that it's in everyone's interest to do so, and that you can make a lot of money doing it. And so that's the sort of the second large industry trend that I would like to see realized in the next 10, 15 years. And I think finally for INCA, we said it. I want to get this factory stood up in Alberta, close to where the hemp is being grown in the Canadian prairie, and then I want to replicate success around the world for INCA. And I'd love to do that sooner rather than later. I'm 72 years old. I'm not going to be doing this forever. I promised my wife several years ago I would retire. I just failed miserably at retirement. Obviously, it's something that I'm passionate about doing. But it's always fun to pass on, have your succession plan, bring up young people who are a lot smarter and a lot more aggressive than I am, and have them, fulfill their own roles as CEOs or CTOs or CMOs. That's another, I think, responsibility of good leadership, is to really create succession and generate enough enthusiasm by younger people of this is something they'd love to enter into, and they see a place for themselves and making a difference in the world. So that's my vision of the future, and it's something that I'm living it out every day.
Now, trust me, David, with the kind of energy that you have, you can still go up to more than a decade, I believe.
What else do I have to do? I mean, I used to surf a lot more. I'm never going to be a good golfer, so so there
I
it
mean,
is.
you can take the place of Pierce Brosnan, try your luck again in Hollywood.
Yeah, maybe. No. I'm way too old for that, man. That's a young person's game, and it's a totally changed world now. That industry is completely changed from when I was in it. Um, yeah, AI is gonna. Well, there are two worlds: pre-AI and after AI.
After,
We have to take AI very seriously in our own factory in terms of maximizing throughput and looking at new ways of developing materials. It's an incredible tool, but again, that I'm going to leave that to the younger folk, the next generation.
Right. Now, good thing that you have brought technology, right, AI into it. So, my last question to you will be, how do you see AI in biocomposites, right? Since you mentioned right now that you need to apply those to produce more hemp, I believe, or rather in your supply chain to, help you with your supply chain. So, where do you see AI coming or technology per se coming into picture?
Well, it's going to touch everything. It will definitely touch control technologies in terms of line efficiencies, manufacturing efficiencies, control technologies. It will definitely contribute to product development where, instead of sort of a kludgy effort to, you build these prototypes or you make formulations and then injection mold those, and I always say make things and break things and see how it comes out. AI, you're going to be able to do a lot more of that in model, in virtual twin. So there's going to be lots of places. It will also help in the adoption cycle, so that when someone's looking at our INCA Biocore material in a wind turbine blade, they're going to be able to plop that in without having to build one and wait 2 years to see whether it breaks. Um, you know, th- there's all kinds of, I would say, development, manufacturing contributions that it will play a role in for Inca, no question.
Yeah. Thank you so much for taking that question. So, what we can do is we can just take a couple of questions from the audience. So, Ankush Sharma has asked, what kind of bioresin is being used to make composites? I mean, that's a
Great
great.
question. So,
Uh,
really, essentially, we're uh, resin agnostic. So, and what I mean by that is, for example, in the auto industry, they are strongly reliant on polypropylene as an interior plastic material, right? And in the past, that has been reinforced with glass fiber and filled with talc. What we do for that industry is in our pre-pregs, we actually are approximately 50% natural fiber and 50% uh, polymer fiber, which is polypropylene, which keeps the cost low, gives them the high performance and the structural characteristics they want. So we are still using petroleum-based materials. In the case of people like McDonald's that wants 100% bio-based material that's biocompostable, we would use PHA as a resin system. It's more expensive, but what we found in work with them is that we could reduce by upping the amount of fiber, natural fiber we can put into that polymer, we can reduce the cost of the final utensils significantly while dramatically increasing the strength. So we actually increased the strength of the base polymer uh, by about 40% and then kept the cost at a constant. So we do look at different resin systems, some of which are bio-based and others are not. They're petroleum-based. I would love to move towards more and more bio-based resin systems. So I'm looking right now at an epoxy that's made from hemp oil that looks very promising. They're already using it in Burton snowboards and some other applications. Those are the kind of things that I reach out to our network or to friends uh, at JEC and others, and really try to source biomaterials for our products.
any more
So
questions? Yeah.
great question. So there's a couple of drivers in aerospace. One of which is reduced weight, obviously. And if you look at airline interiors, all those overhead bulk bins, your tray tables, etc., those are all highly infused glass reinforced plastics, right? And they're heavy. So we really can make a material for that kind of uh, product that would be very interesting to aerospace. Yes, we can achieve the fire rating and the smoke ratings that they need in a commercial airline. And in fact, at Fluxform, we actually did some work with Boeing that now is starting to people are paying attention to. The other thing about natural fiber composites in aerospace I mentioned is that, this whole move towards, you know, non-human driven boats and drones, et cetera, we really have some very interesting properties that they're looking at. And in fact, confidentially, they're starting to put natural fiber in their specifications and having a hard time sourcing it. Or in the case of a company like Bcomp, it's great material in Europe. Bcomp is a great company. It's a biocomposites company, but it's very expensive, and we can really bring down dramatically the cost of what other people have been trying to get adopted into planes, trains, and automobiles.
Aniket, Roy has a question for you. So, do you feel that some sort of incentives and subsidies need to be introduced for the adoption of composites to ramp up the usage?
I don't know. Incentives versus subsidies. I think legislation is important in terms of trying to reduce, plastics pollution, trying to make, looking at life cycle analysis, and most importantly, looking at carbon sequestration. We haven't really talked about that yet, but those market drivers, if you will, those incentives, can translate into subsidies. And I'll give you an example. Every bale of hemp that comes into us, 45% by weight of that bale is carbon. 45% of that is carbon. And when we put that into composites, we've sequestered that carbon. And then when we recycle it, we basically sequester it forever. So the incentives for us is that we were actually granted and will be eligible for a $7 million grant from Emissions Reduction Alberta. ERA, Emissions Reduction Alberta, is financed from the oil and gas companies looking at offset for their emissions. So we get this grant and they get credit for the carbon. If we wanted to, if we didn't get this grant and have to give it to them, which I'm happy to do, we could sell our carbon credits. They're very enticing as far as the values of those. So there are incentives and subsidies that can help, as you point out, ramp up usage in our industry. But I will preach that you still have to be cost competitive. You can't don't base or form a business counting on subsidies, because those things come and go, as you've seen with our friends south of the border now. It all looks good and for the wind energy industry, and then it all looks bad. So renewable energy makes sense on its own, right?
Right.
Solar and wind are already cost competitive with natural gas-fired power plants. That's where it's going to come from. That's where the growth is going to be.
So there's a question like how the quality of natural fiber is controlled and how it's dealt at customer and user end. Are these results vary a lot?
Right. So when we're talking natural fiber, we're really talking about textile grade materials. And so that whether it's hemp in the prairie or jute or flax or canaf, they have to be very clean fiber at certain dimensionality. So we get involved with the quality of fiber, as I pointed out earlier, right in the farmer's field. We talk about genomics and agronomics that enable him to grow plants of a certain size, diameter, certain height, so it makes it consistent for harvesting. We actually want them to lay that fiber down in the field before they bale it up for a couple of weeks, and that enables the microbes to start eating away at the hemicellulose, the sugars in that stalk, and that helps to ret. It's called retting. That helps to separate the fiber from that stalk. And so when it comes into our factory, it's much easier to decorticate and clean. In our own factory, the fiber quality is controlled now by us, but it is a very robust process, multi-step process of removing that long outer fiber from that short inner core, dimensioning it to specific lengths, sorting it. We do an incredible amount of dust collection because we do generate dust. By the way, that's recaptured and we compost that dust. That's about 8% by weight of what comes in is dirt and debris from the field, as you can imagine. So the whole focus on vertical integration and on quality necessitates us being very much a part of that farmer's lives. It's very much a partnership so that we get the raw material in that we need, and then we make sure to process it in such a way that we produce consistent, as you're pointing out, day in, day out, year after year, we're producing the same product from that biomass.
Ankush has a, okay. Ankush has asked that how to maintain the consistency in natural fiber, and also how fiber volume fraction, which is more than 65%, can achieve.
I think what you're asking, and correct me if I'm wrong, we can make products that have in excess of 65% natural fiber in them. In fact, the biocore material, that substitute for balsa wood that I was talking about, that is approximately 84% natural fiber. And then it's a resin binding system, that holds that wood core together, that material together. So our pre-pregs are about 50-50 natural fiber to polypropylene. Our compounded injection plastics are about 35% fiber, is about the highest we can push it, and the rest is polymer. So does that answer, is that the question you were looking for, or did I misinterpret your question?
I think you have answered his question, I believe.
Okay.
Yeah. So I guess one last question for the day. 1 second.
Yeah. So
So
the
Suyash is
first question that
asking.
popped up was how long this stuff lasts. This lasts as long as as glass reinforced plastics. Yeah, it doesn't break down once you compound it with polymer. You've essentially taken that natural fiber and encapsulated it in polymer, so you're not absorbing moisture. It's very dimensionally stable, and it has good product life cycle. The good news is when you're done with that door panel or that material, you can easily grind it back up and injection mold it into other parts. And we've proven that on factory floor. So all of our factories are actually designed, excuse me, to not only utilize our trim waste, so we don't have any waste from our stuff. It goes right back into the hopper and right back into products. But also we can actually take in post-consumer materials made out of our material and put it right back into our program as well.
So we'll take one last question. So Suyash is asking, will biocomposite replace or complement traditional composites?
100%, man. That's the business I'm in. Yeah. And part of the answer to that is that it's important to develop biocomposites that can be used on existing manufacturing lines. You can't ask an injection molder or a tier 1 supplier of interiors for Toyota to retool in order to use your materials. You have to design materials to be able to be drop-in replacements for the incumbent materials, right? If you're asking them to retool or to do it differently, that's a problem. That makes the adoption cycle much, much longer and lowers your success factor, no question.
So that's it. Thank you so much, David, for your time. And I'm quite clear that innovators like INCA are not just talking about green alternatives, but a fundamental shift in industrial DNA of manufacturing. So thank you so much for your time, and to all our beautiful audience. We usually we are I mean we are regularly hosting these webinars on emerging trends and opportunities, and you can like and subscribe to our LinkedIn page, Composites by Stratview, to follow for more updates. Thank you, David. Thank you very much for your time. I appreciate it.
Thank you very much. Pleasure all. Thank you for coming.